Hi, Ryan from 3D Printing Canada. Today we're going to be covering the different styles of 3D printers on the market and what might be best for you. We'll also talk about the different components and what makes up a 3D printer. So stay with us and I hope you enjoy. Welcome back. You know, when I got my start in 3D printing 5-6 years ago, kits, they weren't as good as these. They were wooden kits with millions of screws, sometimes threaded rods held the entire frames together. We've certainly come a long way in only a few short years. And if you're like me, if you've got several printers at home, or you're looking to buy your first one, you're probably looking at the choices on the market and wondering, what's the difference? Do I need to go big? Do I need to go small? Do I need all the features in the world, the biggest build volume, or can I get away with something that's smaller and cheaper? And what's going to be best for my needs? What's going to be easiest for me to use? And how do I know what all these things do? I mean, what is this? What are one of these? And why is it shaped like a cube and this is like that? So hopefully we'll go through some of these topics and understand what makes up a 3D printer in today's market. On the opposite spectrum, we have printers like this, our Duplicator 6. It's a fully robust, large printer, and it has a completely different gantry system to what we're used with the Prusa here. They're two completely different printers, but they both share the same components. In fact, they're not so different at all. They both do the same thing. They both build models up from layers upon layers. They use basically the same hot end, the same kind of belts, the same kind of motors. So they're really not all that different after all. So both of these printers do exactly the same thing, but they both do it in different fashions. As you can see with our Prusa style printer here, the i3 as we'll refer it from now on, it uses a gantry system in both the X, the Y, and also in the Z, in our up and down stage here. The print moves in your Y direction, the tool head in the X, and it forms your model based off of that. When we compare it to our D6 here, however, it's basically the same system. The models are made the same way, in the same fashion, except this time our tool head moves in both the X and the Y motion, and our print bed moves in the Z. So both systems accomplish the same thing, slightly different way of doing it. There's benefits and disadvantages of both of it. This is arguably a simpler printer to put together. It has fewer components, it's a little bit more stable, and it's easier to work on. When you compare it with the D6 on the other side, or on the other hand, it's a little bit more complicated. It's a little bit more enclosed, has a slightly smaller footprint, but it has a lot more rigidity. So what makes up a 3D printer? Well, a lot of components actually do. When we first look at our printer here as a whole, we have a few major components. We have our print surface. This is where the print attaches to the bed itself, and this is where our print is actually built. We then have our gantry system. In the case of this, we have our X gantry, also our Z gantry, and then we have our Y gantry, and then the frame that holds it all together. Now on each one of these gantries, there are many more components. There's many more things that make up one of these printers. When we look at these bright silver things right here, this is our linear motion system. These linear rails ensure that the motion back and forth, or side to side, or even up to down, is precise. Attached to each one of these gantries, our bed gantry here, and what we'll call our tool head here, is what we call linear bearings. The linear bearings ride along our linear rails here and ensure that the motion is nice and tight and smooth. The last thing we want when we're 3D printing is to have a gantry that wiggles around or moves uncontrollably, because that will affect your print quality and the capabilities of your printer as a whole. When we look at this system right here, although it's a lot larger than this system, it has the same components. Our tool head moves back and forth on the X-axis and the Y-axis as well, and the same linear rails are used on that system as here. Our Z stage, where our print bed is here, right here, is completely stationary though. It moves only in the Z axis. So unlike a normal Prusa style printer where our print is moving back and forth, our print here only moves in Z. You can see on the back here, our linear rods and our ball screws are much larger to compensate for the cantilevered bed. So it's a slightly different approach to both systems, but they accomplish the same things. So now that we've covered the three major axes that we have on a printer, we need to understand how they actually move. If you look closely here, you'll see we've got these belts. These are called timing belts. These are very precise, reinforced belts. Attached to the end of the gantry here is a stepper motor. A stepper motor is like a normal motor would be, but it's a lot more precise. It can move down to a fraction of a millimeter at a time. That's what gives us the precision in both our X, Y, and Z axis. What you can't see behind this printer right now, behind these frames on either sides, is what we call our lead screws. Think of them like a threaded rod. They're very simple. They attach to the X gantry here with a few nuts, and two stepper motors at the bottom drive this gantry up and down. They're also very precise, just like these belts as well. So again, we can move these entire gantry up and down, quarter of a millimeter, a fraction of a millimeter at a time, and get us the nice, precise layer heights that we need. It's what makes the system all move. You can't see the belt on the system, it's obscured here underneath this nice cover, but between the stepper motors, our lead screws, and our belts is how we get a precise motion control. And together, that's what gives us nice, precise prints. So, our gantries let us do motions, our stepper drivers help as well, but what do we actually do to get a print? How does the filament go from here to our print bed, and how do we build a model? Well, that all happens here at the tool head. Now, tool heads come in many styles and variations. We have direct drive systems, Bowden systems, single and even multi-extruder models, but they all basically do the same thing. The simplest thing I like to think about is, think of it like a hot glue gun. We're basically just taking a roll of filament and extruding out a hot glue gun tip onto our build platform here. It's a very simple approach, but it works very well for us. So when we look at our tool head here, our tool head consists of a number of different components. This motor right here is what we call our extruder. Attached to this extruder, behind this little lever right here, is an extruder gear. That gear has a number of teeth onto it. And when we push the filament through our extruder gear, the teeth grab onto the filament and it pushes it down through our hot end. Our hot end is comprised of several components as well. Most importantly, it's hot. It gets extremely hot. Some of these printers can go up to 300-400 degrees Celsius. That's as much as you cook chicken wings. So our hot end, while it's a little obscured from this view, consists of three major components. We have our cold zone. It's the area right next to the extruder, right below where we push our filament through. And just like its name implies, we want to keep it as cold as possible. The last thing we want to avoid is having our filament start getting mushy and soft all the way up in the extruder, because then our extruders won't extrude filament very well. And then that leads to a whole source of problems. After our cold zone, we have our heat break. It's a thermal area where there is a sharp transition between hot and cold. That's what this fan's here to help with. You can see here on the side, this little fan will help maintain a cold, even break between our heater cartridge and the extruder itself. And then we have what we know as our heater cartridge. This little block of aluminum right here has a small heater cartridge fitted in the side of it. This is the business end of the extruder. It gets extremely hot, extremely fast. And below that, we have our nozzle. The nozzles range in size from 0.4 millimeter all the way down to 0.2. And on some of our larger printers, you can have even larger nozzles, sometimes up to a 1.2 millimeters in fact. But with size comes a decrease in the quality. The larger your filament, or the larger your nozzle diameter, the more coarse your layers will be, and the rougher your prints will be. So think of it this way: smaller, finer detail; larger, faster, but coarser details. So it's a trade-off that you have to consider when you think about your printers. Do you want to print highly detailed, small, fine parts? Then perhaps a smaller nozzle, a 0.2, a 0.3 millimeter nozzle would be best for you. Are you interested in prototyping large-scale components where quality is not your first concern and you're just looking for structural rigidity? Then a larger nozzle and a larger printer might work for you. So our last major component of any 3D printer is the print surface itself. You see in both these cases, they're slightly different applications, but they both achieve the same thing. Now, print surfaces come in a variety of different styles. We have both heated beds, unheated, removable and fixed, and the materials we print onto vary as well. So first and foremost, why would I need a heated bed? What is a heated bed? Well, it's not something that you would sleep in at night. It's actually for print adhesion. So when we're printing different filaments, such as ABS, PETG, or other exotic filaments, we need to maintain a constant surface temperature. The constant surface temperature on the bed here will help maintain adhesion for the print itself. Last thing you really want to avoid is halfway through a 34-hour print is having your print come off the bed and end in ruin. Not only does that ruin your long print, but can also cause damage to the printers as well. So depending on the filament you're printing, and you'll have to refer to your filament settings specifically, but you may want to use a heated bed in that regard. If you're like me and you like to print PLA most of the time, you can get away without a heated bed. Most of the time, these build tack style surfaces, or even sometimes just blue painter's tape, works wonders for PLA. It really depends on what you're wanting to print though. So when you look at the print surfaces themselves though, we have a variety of different options. Both of these printers right here have what we commonly refer to as something called build tack, or a polycarbonate surface. It's basically a large sticker on here that has a very fine surface texture to it, and it adheres well with most filaments. But that's not the only style available these days. Another popular print surface is PEI, or polythermide. It's a gold-colored film which works wonderful for the printing world. It's magical in some regards, depending on who you ask. Myself personally, I use them both, and I like them both. I like how my prints adhere with these build tack style plates here, and I also like the ease of use with PEI. You can get a removable build surface. In many cases, these may be a magnetic sheet that attaches to the print base, or a flexible sheet held down with some kind of clips. They're really quite nice because you can pull it right off the printer, flex the sheet around a little bit, and your print will magically pop off. But these are not all requirements for your printers. I mean, you don't have to have every one of these features out of the box. A good basic printer, such as the i3 Plus here, is going to be more than capable for your everyday needs. If you're like me and you want to save time and maximize the amount of prints that you can get in a day, you might want to look towards a more sophisticated machine with more of these features. So when you're looking for a printer, whether it be your first or many, you don't have to go for the most feature-filled printer on the market. Sometimes, depending on your usages, like me, if you like to print with PLA, these machines will more than be capable of our everyday tasks. If you find you need a heated bed, or a fully enclosed printer, or exotic filaments that have to be printed up at 400 degrees, and you find a need for that, then sure, go for that high-end printer. Go for one with all the bells and whistles. But really, before you go and commit to your first printer, or your second, or in my case, your 8th or 9th, consider what you want to use for it, and what you want to do with it, and how you're going to grow into the printer. It's better to get a machine that we can grow out of than a printer that you'll never grow into. So hopefully you've learned something here today. Let us know in the comments below. Don't forget to like this video and subscribe to our YouTube page. And also don't forget to click the bell in the top corner to be notified of all our upcoming videos as well. Thank you.